again. Yes, find the time when the small block will fall off the big block, assuming the small block as point object. Acha, how was the test by the way, guys? Kinematics, how was it?
Sir, it was okay. Okay.
What about others?
It was good.
It was hard.
It was hard.
Yes, sir.
Yes, I set the paper on moderate level this time. Although I wrote easy over there.
So there were so many calculations.
So no, calculations are not there that much, but it was
I mean,
like the concept.
every question was different. Like you didn't have to think. You have to think in 30 different ways.
I know.
30 questions.
Yes. So that's why every question was different. That is why I tell you always to practice from different books, so that at least when these type of new questions will come, you will be able to apply those. Easily. I mean, I need to check exactly where how much did you do. I'll send you the answer sheet. Done? What just happened? Initially, this small block is at rest, na? So basically what will happen, the block will remain exactly where it is, and this big block will keep on sliding, right? Will it happen like this, guys? Ground frame. Will it happen like this with respect to ground frame? With respect to this bigger block frame, what will happen? This small block will go backward direction with certain acceleration, right? So that is what you need to see in a frame of reference and all. Or either you can solve it with respect to ground frame, or you can say normal. First thing, what is the acceleration of the bigger block? What is the acceleration of the bigger block? Can you see? Only of 20 Newton force was applied. So the acceleration of the bigger block will be F divided by mass of the bigger block. That will be equals to 20 divided by 5, which will be 4 meter per second square. So this is basically the acceleration of the bigger block. So with respect to bigger block, the smaller block accelerates in the backward direction with how much acceleration? So that implies acceleration of small block with respect to the big block will be equal to minus 4 meter. Perfect. So this will be equals to 0 minus plus 4, so which will be equals to minus 4 meter per second square. So can you see, if you assume that the big block is at rest, then the small block is going in the backward direction with how much acceleration? 4 meter per second square. Now initial velocity is 0, acceleration is minus 4 meter per second square, and if this block is moving to fall off this, how much displacement does it need to cover? And in what direction? So the displacement will be how much? Displacement will be equals to the length of this block, which is basically 10 meter. And what are they asking? What are they asking? What is the time, right? So S is equals to ut plus half at square. And S, please remember, displacement will be minus 10 meter. Why it will be minus 10 meter? Because it is going in the backward direction. Minus 10 meter should be equals to 0 plus half into minus 4 into t square. So can you see from here it will be 2 t will be equals to under root of 5 seconds. And that's the answer to your problem. Check. Is this clear, guys? समझ में आया वाला type? Shall I give you some more questions now?
Sir, yeah.
बोलो.
It's clear, sir.
I'll give you one more easy question. And then we'll do the tough questions. है ना? There is a car or cart, whatever, box cart, and there is a pendulum. Pendulum, you understand what a pendulum is, right? Like this. Okay. Hello.
Yes,
You understand the pendulum? No? There is a string through which bob of mass something is connected, right? So let us say there is a cart, and this is a bob which initially it is at this particular position. Now tell me what will happen. Suppose if I apply a force of, let's say, 225 newtons on this cart, what will happen? Will it become something like this? Can you see, if this thing starts accelerating, then there will be a pseudo force acting on this 5 kg block, right? Yes or no? Will there be a pseudo force? Hello? Hello guys, hello. Guys, I can't hear you. Hello?
Hello, sir. Can you hear us?
Yes, I can hear you. I can't hear Tanish. Tanish was you.
hello.
So that's
Yes. Now I can hear you. So what happens after sometimes when this thing is moving, the pendulum will come to rest at certain position, like shown in the figure. Will the pendulum become like this after some time? From the initial position, will it go like this? Yes or no? Yes or no, guys? From its initial position, will it go like this? Are hi na?
Yes.
Have you ever seen, if you are suppose sitting inside this particular thing, and if a pseudo force is applied on this particular thing, can you see over here how many forces are acting on this block, on this 5 kg block? There is this mg acting in the downward direction, and there is tension in the upward direction, right? Yes or no? So can you see tension and mg will get balanced, but there is nothing to balance this pseudo force, right? If we talk in the frame of reference of the cart, if we are talking with respect to this person who is sitting inside the cart. So basically, what will this person observe? That this pendulum goes in this direction and makes certain angle theta. So the question is, find the angle made by the string of the pendulum inside the moving car. So basically, you need to find out this angle theta. Okay, Shiroja. What do you need to do? You need to draw the free body diagram of this block with respect to cart. So what do we need to do? We need to draw the free body diagram of the pendulum with respect to cart. First of all, can anyone tell me what is the acceleration of the cart? Can you see this block or this bob of the pendulum? Was it lying inside? Was it lying inside the pendulum? Guys?
Yes, sir.
आज का जवाब नहीं देते हो यार, क्या बात है? समझ में नहीं आ रहा क्या लास्ट में? Since the bob is lying inside the car, so the acceleration of the car, will it be equals to the force upon the total mass? In every other cases, the block was lying outside that particular thing, right? So that is why this force which was acting on the was acting on the other object was not making any effect. But here in this time, what happened? Since there was a cart and this block was inside it, so that's why when we take the total mass. It will be 225 divided by what is the mass of this cart, 25 plus bob 5. 25 by 30 is how much? 7.5 meters per second square. So this is the acceleration of the cart with respect to ground. So if I draw the free body diagram of the pendulum, at this equilibrium stage, will it be something like this? This is the pendulum, this is the bob. So there will be this mg acting on this thing. There will be this mg acting on this thing. So mg. There will be this pseudo force acting on this thing. Pseudo force. And what is that pseudo force? Mass multiplied by the acceleration of the cart. And please remember here m will be 5 kg because you are drawing the free body diagram of pendulum. And what else? The tension. Tension. So basically, can you see how many forces are acting? 3 forces are acting on this block. And I can just resolve this thing now. So if this angle is theta, I choose a frame like this. This is my frame. If this angle is theta, then this angle will also be theta, alternate interior angles. Hai na? Yes or no? And if this is theta, then what will it become? And I'll resolve it into two components. This tension. This will be T cos theta and T sin. Since this block was at rest with respect to the cut, hence T cos theta should be equals to mg and T sin theta should be equals to mass into acceleration. So I think what have they asked? They have just asked the angle, right? So shall I divide the two equations? So divide 2 by, so sine theta divided by cos theta should be equals to AC divided by G. And what was AC? 7.5, right? So 7.5 divided by 10, and this will be equals to tan theta. So tan theta is equals to 3 by 4. Hence theta is approximately. Chaliye. So this is your answer. Is this clear, guys? Done.
Yes, sir.
Answer.
Chaliye. Next question. It's not necessary to use the concept of pseudo force. You can solve it in the ground frame as well, but you just need to tell this particular thing exactly what is happening. You need to feel the motion, otherwise, it won't be happening. Now, suppose the question is something like this. So there is a block. Okay. This block is placed on a smooth horizontal ground. And I connect it to a pulley, which is then connected to a block. And another block. So there is this block A, this block B, and this block C. The mass of A is m kg. The mass of B is 2m kg. And the mass of C is 4m kg. Now the question is, if I apply a force capital F, tell me, guys, tell me this particular thing. If this is 2m and this is m, right? Hello? If this is 2m and this is m, then what will happen? This block will go down, right? This B will try to slide down. Every surface is smooth. Every surface or every contact is smooth. So every contact is smooth. Now the question is, find the magnitude F. Find the magnitude of F for which the blocks A and B will remain at rest with respect to block C. This is the question. Please remember, you don't want A and B should not slide. If A and B are at rest with respect to block C, that implies A and B should not slide over block C. Okay, so this is what I want. This is the question. Try to solve it. Try karo. Done. चलो करो, अच्छा क्वेश्चन है. Think. You can discuss among your own if you want. And the only thing with which it will be solved is using either you can use the concept of pseudo force if you want, or if you don't want to use the concept of pseudo force, then you can do normally. Just remember this condition: they should not move over. But that implies B should not slide down, and A should not slide forward. Okay, on this block. So whatever is the acceleration of this thing, the same acceleration of A and B should be there. मैं लिख देता हूँ, चलो hint. If the acceleration if the block A and B are not to slide over C, then the acceleration of A and B and C should be same. So if you draw the if you assume, guys, if you assume that, Control C, you don't need to draw the diagram again. You can just copy paste. You can just draw it on the diagram which you already have. So what if I say the acceleration of block C is A meter per second square in this direction, then acceleration of block B will also be A meters per second square in this direction, and acceleration of A will also be in. Are you getting my point, guys? Hello, guys, are you able to understand what exactly I meant by this particular thing? So acceleration of A also is A meter per second square. Are you getting my point, everyone? This is the hint which I can give. Now you need to draw all the forces acting on C, B, A individually. Please remember, B will also be in contact with C, A will also be in contact with C. There are lots of contact points. Normal reactions are necessary here in this case. Also, can you see this C over here? Guys, can you see this thing? The two tensions acting on this two pulleys will be assumed to be acting on this block C, na? So try to do all the 2 mg tension T. When you will draw the free body diagram, please include all the forces T and mg. There will be 4 mg over here. A normal reaction from the ground, let's name it as N1. This force F, है ना? उसके बाद में one normal reaction from this to N2, and the same N2 will be acting on this in this direction, and one more normal reaction N3, and this N3 will be acting. So basically now I have drawn all the forces. Please draw the FBD and try to solve the problem. The answer should be 14 mg. The F should be 14 mg for these two. I'm giving you 2 minutes to solve. Please do it. Draw the free body diagram, and please, whatever free body diagram which you will be drawing, those will be with respect to ground. The FBD of M with respect to ground, FBD of 2M with respect to ground. Now after this I'll teach you how to draw the FBD in the another's frame, okay, and FBD of 4M with respect to ground. So draw all these three and then make the equations and then solve. Okay, chalo karo. I'm giving you 2 minutes to solve it. At least with the ground frames you need to solve.
Sir, hello. Hello.
So you there? Hello, sir. Are you there?
Manaya? So if we talk about M with respect to ground, so first there is this Mg acting downwards, there is this N3 acting upwards, there is this T acting in this direction. So can you see this force, and this force are acting on block A? So we drew all the forces, and this block was accelerating with an acceleration of A with respect to, yes or no. This is also accelerating with A over here, and this is also accelerating with A over here. So that is the common point which you need to understand. After this, N2M, so 2mg acting downwards, T acting upwards, and this N2 acting towards right. So this force is done, this force is done, and this force is done. Yes or no? Now when we draw the FBD of 4m with respect to ground, so see, this 4mg acts downwards, so 4mg acts downwards. उसके बाद N2 towards right, this N2, N1 towards upwards, so N1 towards up. So we draw N1, 4mg, N2 done. Now this N3 downwards, N3 downwards. So this is also done, and this force F is acting towards right. So you draw it like this. Okay, you don't draw like push, you always draw like pull, acting away from each other. So these forces are done. Sir, what about these two T's? Can you see these two T's which are left? So these two T's have to be drawn in the free body diagram of C only, because this is directly connected to a pulley. So these two T's will be drawn in this only. There is one T acting down here and one T acting here. Is this clear? And this thing is accelerating with respect to in this direction. Yes. So now all the FBDs have been drawn. Can you make the equations? Can you make the equations, guys?
Yes, sir.
Can you make the equations now? Can you see N3 is equals to mg and T is equals to m into A? Yes or no? N3 is equals to mg and T equals to ma. I have not used the concept of pseudo force over here. The second approach I'll tell you with the help of pseudo force. And this is equals to N2, T is equals to 2mg and N2 is equals to 2m into A. Yes or no? Yes or no, guys? Am I doing it correct? 4m. N1 is equals to T plus N3 plus 4mg and F minus N2 plus T, because N2 and T were acting in this direction and this object was accelerating towards right. So hence F should be bigger than N2 and T together. So F minus N2 plus T should be equals to 4M into 1. So these are all your equations which can be formed with the help of the free body diagram. Now let's solve them. What do you need to find out? You need to find out F. So F will be equals to 4ma plus N2 plus T. Yes or no, guys? Yes or no, guys? With the help of this equation number 1, will we get this? Yes or no, guys? अब मैं इक्वेशन भी सॉल्व कर रहा हूँ फिर भी N2 is equals to twice of ma, so 4ma plus N2 की जगह पे twice of ma plus T, can you see T is equals to ma, so I am writing this. So from equation 2 and equation number 3. And this is from equation number 1. F will be equals to 7m into A. And from here you can see F is equals to 7m, right? Can you see this thing? I told you that this whole thing will behave as a common block. So this thing which was there when it was accelerating with a common acceleration, you can assume, see, m, 2m and 4m, you can assume this whole thing to be a common block of mass 7m with a force F, and this thing is going in this direction with an acceleration of this. Are you getting my point, guys? So you can assume this thing like this. Anyways, now F is equals to 7ma, ये सब हो गया. Now can you see over here T from equation number 3 and equation number, let's say, 4. Equation number 3 and equation number 4, T is equals to ma and T is equals to 2mg. So can I say from here ma should be equals to twice of mg? So m say m will get cancelled and acceleration will become 2g. Yes, I can put this acceleration over here. So from here 17m into 2g, and your force will become 14 mg. And that's the answer to your problem. Okay. Tell me from where are you done drawing the free body diagram of everything? Are you done drawing the equations, guys? Please check it. Don't miss anything. Done, guys? Have you noted it down? Guys, are you done?
Yes,
No.
sir.
Yes, sir.
I'll give you a similar type of question, but similar type, है ना? Not similar problem. Question. Suppose there is this block of mass m1, and on this block I have placed another block m2. This is smooth. All surfaces are smooth, and this whole thing is placed on a ground. So this ground is also smooth with this. Okay. This angle is theta. Now the question is, if I push the wedge by a force F, so when the system shown is released from rest, find the find the value of F for F for which the block of mass m will remain at rest over that. But similar type, I don't want this block m2 to move over this block, right? Acha, I was teaching for don't write this question, guys, as of now. I was teaching you with the help of pseudo force how will you do it, है ना? Guys, I'll be teaching you how do you do it with the help of pseudo force. So method 2 will do. Method 2 with the help of concept of pseudo force. The first thing first, you'll draw the free body diagram of 4M. Can you see the block A and B were over what? The block A and B were over this 4M, right? Control C. So you need this at least, enough, because since A and B were, this is not A and B, this is block C, okay? The bigger block. Now, if I draw the FBD of 2M with respect to block C, guys, please remember, can you see this block C is accelerating with an acceleration A, right? Yes or no, guys? Is block C accelerating with an acceleration A, right? So what all forces are acting on this 2M? The forces were N2T and 2mg, right? So I'll draw those forces because those forces are acting. So N2T and 2mg were acting on this. Since you are drawing with respect to block C, then will there be a pseudo force as well? So if block C is accelerating towards right, hence there will be a pseudo force on this 2M block towards left. So I'll write this 2M. Can you see the mass of the object multiplied by what is the acceleration of the observer? A. So basically this thing is a pseudo force acting on this block, and this whole thing is at rest with respect to blocks. Yes or no? So can you see the difference between the free body diagram of 2M with respect to ground and with respect to block C? Compare both of them. You'll find the difference, right? Similarly, you'll draw the free body diagram of M with respect to block C. What all forces are acting on M? Can you see? N3 upwards, Mg downwards, T towards left or right. So N3 upwards, Mg downwards, and T towards left. Now there will be again a pseudo force acting on this block C because we are experiencing with respect to block C, right? So on block A there will be a pseudo force which will be equals to mass of the block multiplied by acceleration of the object. The mass of the block M was M multiplied by acceleration of this. So basically this is the pseudo force acting on mkg, and this whole thing is at rest. So can you see, guys, when you make the equations, if this is at rest, can you see if you make the equation n2 will be equals to twice of ma and t is equals to 2mg. Similarly over here t is equals to ma and n3 is equals to mg. So can you see, guys, these two equations, these four equations and these four equations for m and 2m, they are one and the same thing. Try to compare these four equations with these four equations which we made. So equations, since the equations made are same, so on solving you'll get the same result, right? So hence these two methods are correct. You can use either the concept of pseudo force or either you can use the concept of from ground front. Whatever you are comfortable in, just try to do that. Okay? Is this clear, guys? Please write it and then we'll start with the next question.
Call me back. Is it possible you can call me on the number? I can call you from my friend's number. Hello. Kunal Kunadkar. TDD LNT कैसा लगा वो? TDD LNT कैसा लगा?
LNT का
LNT तो कैसा लगा?
LNT अभी done, guys? Are you done noting down?
Yes,
Yes,
sir.
Wow, one more result came. Jeffin from 12th grade. I had 3 students in 12th grade last year, and
Nice.
two were in school and matlab the our own program, and one was in the evening batch which was from JSS Kavya. So basically the results for Jeffin also come, and his scores you will See, it's like maths 95, physics 95, chemistry 95, English 95, and computers 96.
So wait, Kavya came for crash course or she came for the
She came
full
for
course?
the full course.
Oh.
All these students were full course. Aditya, one more result is yet to be, disclosed. So
Okay.
अच्छा है, one student, Kavya scored maths 100, physics 97, and chemistry 93. So Jeffin also
Nice.
scored good, nice.
So sir, they did all great, basically.
Huh?
They did great.
They did good. Good. Very good. See, ultimately your percentage should be enough so that you can get, good colleges, right? And nowadays IIT, JEE and NEET people, they have like, a criteria when you go into college admission and counseling time, no? So you have to have like more than 80% in your boards exam. Then only you will be able to get a good seat in a good branch in that good college. Are you getting my point? The school marks also matters
Yes.
these days. Initially, at our times when we used to give the exams, it was like uh, when our exams used to happen, no? तब उस time पे the criteria was for school exams was only 60% marks. So if I would have performed very good in JEE and all, and I would have got even like 61%, then I would have taken IIT Bombay mechanical branch. Are you getting my point? So like
Yes,
that.
sir.
I got selected in IIT as well, but my rank was not that much good. It was 7,000 something. So I was not getting a good branch in IITs.
Okay.
Because I was an average student. No? The main point was this only. You need to be, become above average. Otherwise, बहुत दिक्कत होती है बाद में. Not at the time, because when you are stuck in the range of, like, these mid students in JEE, mid-rank students. Like, for example, in JEE, the rank should be like, 6,000 to 10,000. Are you getting my point? So these 6,000 to 10,000,
Yes.
they are not offered BTech program. They are not engineers. They will be not offered engineering programs. They'll be offered like programs like, either MSc, BSc in that engineering, in this science, chemical, physics, applied physics, something like this. So they will be not given an engineering degree. They will be given, science degree. So with the help of that science degree, I can go to, some higher education, like, if I want to become a theoretical physicist, suppose. I'm giving you just an example, so then I can, have that. Then that rank is useful. I can go to ICERs and all. So वो एक अलग ही branch है. So
So you know
anyways,
any IIT graduates?
me, are you kidding me?
No, I'm just asking.
My whole group is mostly IITians and NITians.
Oh. Okay.
चलो अच्छा है, nice thing. Applicated and JEE. All the very best. अच्छे का मैसेज आया वही, sir I got this marks. चलो anyways, try to do this question now guys. Last question for today. Try to do this question. Find the value of f for which the block of mass m will remain at rest over the wedge. Again, what will you do? You'll draw all the forces. So basically there will be this m1g acting downwards. Yes or no? Let's say
Yes.
n1 acting from the ground upwards. And can you see this m2 will be trying to push it downwards to n2 in this direction? On this red, there all the forces which are drawn in red are acting on m1. Then what all forces will be acting on this m2? Can you see this n2, which was this block was pushing this to, for every action there is equal and opposite reaction. So n2 in this direction, m2g in the downward direction. So only two forces are there, right? Yes or no, guys? So if I draw the free body diagram of M2, will it be like M2G in the downward direction? and N2 in this direction. Yes or no? And please remember, this is with respect to ground. I'm drawing with respect to ground. Now, similarly, FBD of M1 with respect to ground. It is N1 in the upward direction. Can you see this N1 in the upward direction? N2 in this direction. And M1G in this direction. Apart from this, there will be this force. Can you see this F, which is also acting on the wedge? So this force, capital. So these are all your forces which are acting on M1, and these are all your forces which is acting on M2. Now, if the whole thing, can you see, for which the block of mass M will be at rest over the wedge, that implies the whole system should move with a common acceleration A, right? This is, I told you already in the previous concept as well. When there is no relative motion between the objects on the system, then hello.
Yeah.
So basically this will be A and this will also be A. Now if you are solving with respect to ground, there is no need to solve it. Please remember, both the objects are accelerating. So which frame you will you choose? Will you be choosing this frame? Yes or no? Will you be choosing this frame? I told you, always remember whenever you have acceleration, then always one of the axis should be in the direction of acceleration. So even for this object, now we are not choosing a frame like this. Are you getting my point? It was accelerating, that's why we have to do it. Anyways, so now if this angle is theta, so can you see the N2 will make an angle theta over here, right? So I can say this angle is also theta and this angle is also. So once I do that, then I can resolve this N2 into two component, N2 cos theta and N2 sin theta. And here also I can resolve this N2 sin theta and N2 cos theta. Is this clear? So from here, if I make the equations, can you see the object was not flying up or down? So this N2 cos theta should be equals to N2 cos theta should be equals to mg, and this N2 sin theta is providing the net acceleration. So N2 sin theta, and what is this mass? M2. So is equals to M2 into A. These are the first two equations, and the second set of equation will be like from here, N should be equals to M1G plus N2 cos theta. So this was N1, right? Sorry. So N1 should be equals to N2 cos theta plus M1G, and the second equation will be F minus N2 sin theta should be equals to M1. Is this clear? So now basically what to do now? Can you see N2 sin theta, if I put it over here, if it will get F minus M2A is equals to M1A. एक second guys. So चलो solve करो guys. Solve it please. So can you see from here, F will be equals to this M2A will go over here and it will become M1 plus M2. I told you the common block. Can you see it is behaving as a common block? Force is basically the sum of the two masses, the total mass into acceleration. So this is this clear? Is this clear guys? Hello? Is this clear, guys?
Yes, sir.
But if I can just replace this acceleration, then my answer will be correct. So can you see from here? If I just divide these two equations together, so can you see sine theta by cos theta will be equals to m2a upon m2g. M2 से m2 will get cancelled. Tan theta will be equals to a by g, and here from here you can see this particular thing. A should be equals to g tan theta. Now you just put this g tan theta over here, so you get f is equals to m1 plus m2 into g tan theta. That's the answer to your question. Okay. Yes, guys. Always remember this thing note, hai na? This thing as a note. This is a standard result which can be used in any different problem. Always remember, if there is a wedge and there is a block, every surface is smooth. If this mass of this is how much? Mass of this is m1 and mass of this is this. Whatever be the masses, I don't care. If suppose, guys, if the common acceleration of this thing is a equals to g tan theta, then the block, the smaller block, will not slide over the so is pe based you can be asked a little bit questions, right? Is this clear, guys? So with this thing I'm done with NLM chapter, except constraint relations, but until unless I want to get the practice which I want on normal questions, I won't be doing that advanced stuff with you. So when you will be done with that advanced stuff, we'll take it in between some lectures and all. Don't worry, we'll never leave any topic. But the point is, I want the basic practice for all these type of questions before. Then only I'll be able to do that. Enough? Is this clear, guys? So once you will be able to done the basic practice, then tell me. Then we'll start with the constraint relations. In the next class, I'll start with friction. Okay? Hello?
Yeah,
Hello?
yes, sir.
ठीक
Yes, sir.
एकदम से नींद खुलती है सबकी, है ना? मतलब पता नहीं क्यों म्यूट करके रखते हो, I don't know. So this is it for today's class. Thank you very much. I'll be sending you the notes today, and most probably I think I'll send like 2 different lecture videos for this lecture, because it got recorded in between because my laptop got shut down. So anyways, are you done, guys, writing?
Could you send the notes?
Yeah, I'll just send the notes.
Okay.
No.